Hello, how are you? You're so welcome. I'm so excited. I hope it's new day, so you are doing fine. Actually, obvious. That is obvious, right? So today, I think I'm going to give you a new knowledge. Actually, if you don't know, but today you're going to know. So we are going to start on mirroring technology, actual technology. In Huawei, we are going to see this. What is mirroring? How do we configure mirroring? Actually, it is very simple protocol, but very useful indeed. You're going to use it a lot in your once you are a network administrator. So what's important? What are the benefit of mirroring technology? So behalf of anything, I think I'm going to start. What is information? What are the informations? What are the data? Why do we need some time to collect the data? So in computer networking, we are collecting data because of different things. One of the most important things that we are using as a key of collecting data is when it comes into the maintenance and troubleshooting. Maintenance and troubleshooting sometimes will require you to collect some data so that you can use them on troubleshooting or maintaining the device that is under operation. So another thing that is very key or it's very important concerning data or data correction is network optimizations. When we need to optimize the performance of a network, we have to start the flow of traffic. We have to collect the data that is already existing to the network so that we can perform or can make it better. So another thing that is very important actually is analysis, data analysis. So we are collecting information because of analysis. I mean, for the case of security purpose, as you can see, some network administrator need to analyze every packet that is enter or leave the network, so that to ensure that no any other traffics or any kind of attack will be suspected to the network. So that is a very important thing that you need to know when it comes to data collection. So in computer networking, we can have many ways of collecting data, but these are the best. These are the best, and these are the two. So the first way is using splitter. So we are deploying splitter in inline mode so that we can split the data. The data that is needed to be corrected, we have to tap a splitter. I assume, let's say, okay, just take a switch. Okay, let's say this is a splitter. So this is a splitter. So we put the splitter in the line, in the connection. So the splitter will, what we do is the splitter will split the data. The data that is needed to be corrected. Assume PC1 is needed to be corrected. The data of PC1 needed to be corrected and maybe forwarded to a certain node in network management system, administrator where is actually settled. So the splitter will split the data from PC1 to network management system. The other data will be, so splitting this physical meaning of splitting the data is actually not good, because sometimes when we split the signal, that means even the power is splitted. So the performance actually deteriorated. That is the main thing that we need to know. So then another way that we can use actually using the NMS, network management system. So this is actually the main way that we are using most of the time in the network, deploying network management system. This having this system software will allow you to collect the information in a certain time and analyze on your own time. Yeah, it's very interesting, but we need something good, something nice. That's something that does not affect the data forwarding. So other methods that, as you saw earlier, example the physical intervention. Example, putting the splitter in between the device so that it can track all the traffic that are passing to that line. That is actually affecting the data forwarding. Yeah, putting that device in between, that means it adds a certain delay. It adds a certain way that we can count as a delay, so the returns will increase. So so we need something which is very explainable, that does not affect the data forwarding. So here we come up with mirroring technology. So Huawei offer this kind of technology that will just give us how do we collect information, what are the benefits of collecting information through the mirroring technology, and so on. So mirroring technology, actually it is copying, so it is copying the data, or it is copying the traffic from a certain port to a certain port without affecting actually the data forwarding. So assume this is our network, this is our RAN, let's say our RAN, and this is our administrator, our network management system. So we need maybe to forward, I need you to actually take the traffic, right? We need to tap the traffic from the LAN to network administrator without affecting the service. So without affecting the data forwarding. So deploying mirroring technology will give us, or will enable us to copy or to reflect, to copy the data from this interface to this interface where the administrator actually settles. So we just copy the data. We don't split the data. We don't interfere the data forwarding. We just copy the data from the interface that is used to come in the router, and forward it to the interface that actually the server or NMS is there. So this technology is actually called mirroring technology. So mirroring functions copies the packets of a specified port. So this port that we actually tap, we actually copy the data, is called mirrored port, because it mirrors the traffic, it mirrors the packets, and the port that is used to forward the data or package to NMS is called observing port. So we mirror and then we observe to a certain interface, right? So advantage of using mirror technology, first of all, its data collection is convenient, and does not affect even the data forwarding, so that is very important. Also, another thing is real-time data flow are corrected. So at real time, you can collect the information and ensure reliability of information. Yeah, that is all about mirroring. So that is actually the advantage, or we can say the introduction of mirroring technology. So how do we configure mirroring in Huawei? So this lecture will make you having a nice understanding, a good understanding, so you can configure even by your own. So for the case of configuration, let's say we have this network have this have these nodes, have a LAN, and have NMS. NMS is where we manage our network, is where we centralize our management in our network. So NMS actually manage resources, manage services, also manage users in the network in a centralized manner. So having NMS is very important in your network. Once you need to reduce the whole variety of configurations and managing device one by one, that is very older way of managing it. So nowadays we are using NMS because it's very simple to manage even the large network, because first of all it gives an accurate way of management and so on. So NMS it's where that is supposed to reflect the data. So first of all, just we need to we are saying that this LAN using this network 192.168.50.0, and actually if this is a network, and this one this PC1 has this IP, and this has this IP. Actually you can see this IP. Yeah, sure, let's put 3 because then of it's PC3, so it's 3. Come here, yeah, sure. Can you cancel? Yeah, sure. Yeah, sure. 3. Apply. Yeah. Okay. It's not case. So come on. If it is 1 3, yeah, okay. Come to this PC. Yeah, cancel. That was operation learning. So this is our gateway IP address. So I'm expecting this IP, because it's gateway, it is present in a router. The router that is connected to this laptop, it has this IP address in one of its interface. So let's confirm. Go to the router. Yeah, router. This is the router. Very interesting. Okay, you can say display IP interface. Yeah, believe. Check configurations. Oh yeah, we found that one of its interface, which is Giga000, has IP address which is the gateway IP address of PC1 and PC2. So can we achieve to ping PC1 from router? Let's try. It's a game, right? Let's try if we can reach. So ping 192.168.50.1. Yeah, sure. We'll reach. So IP connectivity between router 1 and the PC1 is well achieved, is well actually established. You can say that. Also, what about PC3? Yeah, you can ping PC3. Just change the last letter. Yeah, 2. We can also reach a PC3. So I'm able to ping from router 1 to PC1, router 1 to PC3. That is perfect. So if it is perfect, now I need to start or to analyze or to correct the data that is coming from PC1 to router. They say this guy maybe wants to surf maybe a certain web service in the internet. So the path actually will be from PC1 switch router to the internet. So router is a gateway. It's a gateway node. So it is possible. It is possible that we can analyze the traffic from PC1, PC3 to internet, also from the internet to. So okay, let me add this. Why do we need data analysis? Data analysis sometimes will help us when increasing the network security. So if an administrator wants to make sure that the traffic that is flowing in the network is authorized, so sometimes he doesn't allow the traffic that is not authorized to flow into the network. So we need to actually analyze the data most of the time. Often we can use the methods of analyzing. So there is different tools that is used to when it comes to data analysis. One of the best tools that I'm actually one of my favorite is Wireshark. So we'll see how to use Wireshark in here. So it's very interesting. Let's see. So also for this case, observing port is where the NMS is connected. So I don't think if we need IP connectivity, we just need to map the packet flow from mirrored port, as I said, and to observing port. So take a note on this port. This is observing port, and this is what mirrored port. So we are mapping from mirrored port to observing port, because observing port needs a certain traffic to come in, but mirrored is where we copy the traffic that we need to analyze. Okay, so that's cool. So just assume. Okay, can I achieve to see the traffic coming from PC1 to PC2? Let's say let's do data capture. So right click to this on this interface. Right click. Actually, no. So yeah. Okay, yeah, remove connection, that is not capture data. Yeah, capture data, then say this interface. So I'm capturing data. Wireshark is started automatically. Yeah, sure. Now Wireshark is on. Sure. But Wireshark, what does it say? Wireshark? Nothing is running. Why? What's the problem? Yeah, sure. Because there is no traffic flow. That's why Wireshark, when it capture the traffic flow on this interface, it has nothing to display. It has nothing to display because of data. There is no data. There is no data flowing on this interface. So can you also maybe let's capture here this interface here. We just okay say yeah, that's data capture. Yeah, sure. For this interface, yeah, there is traffic flow, which is STP, as you see. Wireshark can even see the STP packets that are used to change IP address to MAC address. As we know, one of the most very powerful tool in computer networking is RSTP. No, actually not RSTP. LEAP. Is it LEAP? No. Or address resolution protocol, ARP. Sorry for that. So okay, can we try to ping this interface, the interface on the router, which is gateway? So because I was able to ping PC1 from router, so can I try to ping this gateway IP address from the computer? Okay, let's try to ping. Let's try. Okay, it may be very interesting. So ping 192.168.50.254. Yeah, sure. You see, I can reach. So I'm from PC1, but I can reach PC. I can reach the gateway. I can reach the interface from here. So can you go to Wireshark? Let's see Wireshark. Oh, Wireshark has captured something. Has actually captured something. Yeah, let's see. Actually captured the first packet is ISMP. So this is a ping. This is a ping packet. Wireshark has able even to capture the ping packet. So it captured the ping packet. So can we see it in detail? Yeah, it opens. Okay. So it says that Ethernet to go destination address. Yeah, this one. I think this address will be the frame of IP MAC address of the interface of the router, the gateway itself, and the source address. Oh, look, 0762. Actually, this will be the MAC address of the laptop. So that packet was from PC1 to gateway. Can you see the MAC address of this? Sure. Do you see? It's the same. It's the same as this. That's why. So this packet was from PC1 to the gateway, to the destination, to the gateway IP address. What about what? Can I just come to the IP protocol? See the IP protocol. IP protocol, yeah, version 4. That means IP version 4. Header range. Okay, this is the weight of the packet. Actually, SMP. This is the protocol number. Always the SMP is protocol number 1, right? Okay, there is a source IP address and destination IP address, as you can see now. So this packet, it is from source, this IP address, which is PC1, to destination, which is gateway. Actually, the IP address that is in this interface. So the Wireshark actually captured the flow of traffic from PC1 to PC4, but from this interface we are not able to see anything because we didn't try to capture or to forward the traffic. So my intention is to mirror traffic, auto traffic flowing to this interface and forwarding them to this interface. That is my intention. You have to understand that, right? So that is mirroring technology. So let's do configuration. You can see even the forwarding of traffic. So first of all, let's ping an infinity. So ping, then put -T. That means endless. So it will be continuing pinging until you just stop it manually. So can it come here? Let's see. Data capture. Okay, data capture. Yeah, this one. Delete it. Sorry. Yeah, as you can see now. Yeah, the packet is still flowing. The packet is still flowing. Do you see the ping packet still flowing because of the ping? Yeah. So first of all, also you can just come here, also ping the same command, ping the same command, ping the gateway 168, yeah, .50.1, right? Yeah, .1, sure, .254, yeah, ping, yeah, it will end with 5 packets, yeah, okay, ping it endless, so that I can capture the data well. So come here, see the data traffic. Now we can see the packets that are flowing are from three different address, from 1, 253 and the 250 and the 255, 1, 254 and the 3. It's a different IP address, right? So I need now to mirror the packets that are from here to here. As you can see, this interface not yet receiving any packet, no any packet flowing to this interface. So I have to map through the configuration without affecting the data forwarding. So I'm just mapping the traffic, all traffic flowing to that interface to this interface. Okay, go to the router itself. The configurations are just too simple. Yeah, simple to understand, simple even to configure. Yeah. So okay. So first of all, you need to specify which will be your observing port. Which port will the administrator or will the collector be connected? So this one will be my observing port because NMS or collector is located to this side. So when I'm forwarding the traffic that I copied from the mirrored port will be collected here. So this one is actually trusted for analyzing the data. That's the first one. So I need to tell the router this interface Giga 001 is my observing port. So this is what I'm doing now. So you have to say observe port, then say interface, interface Giga what? Giga 0001. Yeah. Only one observing port can be configured. Oh, I've already configured this. Okay, this can check. Yeah, now it's already configured, right? The command is very simple. Say observe port, interface Giga. That means now we are telling the router this interface will be my observing port. For any data that is mirrored from a certain port, from a source port, should be forwarded to this observing port because it's where the NMS is connected. It's where the administrator is waiting for analyzing the data. So yeah, sure. So that is first. The second thing, you need to tell the router which one will be the mirrored port. And when we mirror those traffic, where should we forward the traffic? Yeah, so enter into the router. So for the case of mirrored port, we have to enter into the specific interface, the specific port that we need to mirror the traffic. So for my case, Giga 000 is my actually my interface. So I have to enter into the interface view, say interface Giga 0000, yeah, interface. Then inside I have to say mirror. So mirror, because now I'm mirroring this all traffic flowing into this interface to a certain interface which is called observing port. So I'm mirror 2. You have to mirror all traffic flowing in this interface to which interface? Observe port. Also, if it's observe port, there is two things you have to understand. In which direction? When the traffic is entering into the router or when it's leaving the router. So we can map the traffic when it's entering the router or leaving the router. So if I need maybe to mirror the traffic when they entering the router, I have to say inbound. but if I need to mirror the traffic when they are leaving the router, that interface that is going to mirror the traffic has to be the gateway, has to be the external interface to the network, to the internet and the other network. So for my case, I would prefer to be in, because I don't allow any kind of attack first to enter into the router, then when they are leaving, though, yeah, we can just yeah. So we have to defend when we are entering the router. So say enter inbound. So that is very simple command. You have to say mirror to observe port. Okay, sure. So say now display current configuration. Current configuration. As current configuration, you can see now we have specified the observing port. Also we have what mirror to. So now we have mirrored all traffic flowing to this interface. To what? To observe port. What is the observe port? Observe port is Giga001. So Giga001 is this one. So for this case now, I can come to this interface to see if there is any traffic flowing. So I'm starting data capturing. Start data capturing. Come on. Yeah, data capture. Chop. Yes. Yeah, now as you can see, now data started flowing. So this information is the same as what here. Okay. Can you start data capture? Yeah. Yeah, as you can see. Can we have those both? Yes, this one. Yeah, okay. This one and this one. Okay, now you can see data capture. Yeah, so the main thing that you need to know is, yeah, so this is how we actually map the traffic. So this is very passive way of analyzing the data, of data collection. Passive way. We are not actually interact physically with the data flowing. We actually copy the data from their direction, from their flowing, then we map them to, we forward them to the certain port which is waiting for the for data collection. So that is how we configure mirroring. So this way of configuring, we are calling it port mirroring. So this is the port mirroring. Why is the port mirroring? Because we are not even distinguish which one we need even to analyze the data. Assume if I'm interested with only PC3, I need only PC3 to be captured, the data to be captured. Do you understand me? I need only PC3. I don't want the traffic of PC1 to be analyzed. So I need only PC3 to be analyzed. The traffic of PC3 has to be analyzed when they're entering into the router. How should I do that? How can I achieve that thing? So for this port mirroring, I can't achieve because mapping is happening to the whole interface. So I'm mapping everything to the interface. I'm mapping everything. I'm analyzing everything to that port. That is called the port mirroring. So when it comes to traffic mirroring is when I'm interested in a certain traffics. Then that traffic I'm going to classify, and I'm going to analyze or correct the data of that interface alone, nothing else. So I'm going to explain traffic mirroring in the next lesson. So if you have any question, you can comment in below. Yeah, sure. This is what I can show you right now. So what you have to understand, very simple. Just have that, have the main understanding what is port mirroring technology and whatever. So okay, thank you. You're so welcome.